Hi guys, today I want to speak about a very important topic when you're building a battery pack, and this is what happens when you have a sectional battery build. When we're building a battery system, we are talking about strings and cells in parallel. In those strings, and in my case we have a 16S battery setup. So 16S means we have 16 strings of cells connected in series to reach our final pack voltage. What is now a sectional build? So when we have to discontinue and divide this string into separate sections, that's a sectional build. So in my case here, this is a very extreme case. I have in every of these compartments I have 3 cell strings in series, and then my section is finished. Then I have to use a jumper and go into the next section, next jumper, next section, jumper again, and so on and so on. And what now the importance is with build like this is what happens with measurements which some devices have to take from this pack when this pack is divided by this and when there are jumpers here in between. In a previous video I have explained to you how you can calculate your wires here in your battery pack, and I have told you we can simplify. We can use a formula which is 5 amps per 1 square millimeter. That would be your maximum amperage which you can put through that wire, right? So in my case, when I look at my wires here inside the pack, so all these jumpers are 16 square millimeters. So the maximum amperage we want to use there is 80 amps, and my maximum amperage which goes through the system here is 60 amps. That is when all 3 chargers are engaged and charging, and that's exactly what is going on at the moment here. So this formula, which is just about currents, what can your wires withstand safely, continuously. In that video I told you this formula, you will be fine with that when you build your pack. And then I also said, like, voltage drops in your system because wires are always short in a battery system like this, you can actually disregard it. When I said that, I meant that from the efficiency standpoint of your system, right? So if you look at my wires, if I would double up those sizes, those diameters, it would from efficiency standpoint not bring a lot. You would maybe have a 1% better efficiency on your system, but on the other side you would have to spend a lot of money for that extra copper, and it would not bring anything over the lifetime, probably. There's one case where this cannot be just said like that about the voltage losses, and this is about what we're talking today when you build your battery pack in sections. This is even an issue for somebody else. Watch other battery builders on YouTube, for example. You will always see people making some cell arrangements. They put the cells into some wooden boxes or plastic, whatever, and they would take, like, maybe for the 16S configurations, 8 cells in series, then take a jumper and go into other 8 series, or you can even see configurations, maybe 4 cells, 4 cells, 4 cells, 4 cells. And all these configurations, of course, they do have interruptions by jumpers, right? Always when you are setting up something which is just using bus bars, and this goes from one cell to the next group, right, always with a bus bar, this is perfect. There will never be any voltage drop or anything considered on this bus bars, because the only point of voltage where it could drop is somewhere here between the cell groups by itself, and there is no voltage drop to measure because the cells are right next to each other. But then when it comes to the point where you leave one cell group and go to the next, there you have to put a jumper. And what this jumper is actually doing, I will just show you now. What it means for other devices in your system, like a BMS, like these ones here, which come with a harness, and then they take a measurement at every cell group. So what that actually means when there's a jumper in between to your measurement, and what it can cause, what kind of confusion it can cause actually for you to understand what's going on in this pack. That is what we're talking about today. As you can see here, I have 6 sections. That also means that I have 5 jumpers here in this pack, which are simply connecting one section to the other. And a jumper consists of a piece of conductor, and then you have your lugs which are crimped on the conductor so that you can connect it somewhere on your terminals. The jumper will actually have a defined property. It will have a defined resistance which comes from its length and resistance per millimeter or whatever per length of a conductor, and then the resistance which comes from the crimp connection to the lug. So this jumper now, or this one, they are acting now as a fixed resistor. So similar like, you know, a shunt which is used for our current measurement. It is a piece of fixed resistance. You could measure that resistance, but what that means, that it is a resistor, that means that now Ohm's law is coming into effect here. So what does Ohm's law say? Ohm's law says voltage is divided by resistance times the current. Our resistance is more or less constant. It is just changing by the temperature a little bit, but that we can neglect. Our current is changing. So if the system is idling, zero current means we have then resistance times zero, voltage drop over this jumper will be zero. But now in this case we have resistance times 60 amps, and this will cause a voltage drop. The higher the current, the higher the voltage drop. We can check that here. Let's connect our multimeter from this side of the jumper to this side of the jumper, and you can see now we have a voltage drop of 0.032 volts. So 32 millivolts voltage drop on this jumper here from one side to the other, one cell to the other. So we can now of course check a longer different jumper here. I have one very long jumper here. This goes from here to the cell group on the down there. This is a 1 meter jumper, and let's see how much voltage drop we have on this one. And here you can see 0.071, so 71 millivolts of voltage drop from that cell to the other. Now already someone will say, okay, so why don't you double up that jumper conductor there? So instead of 16 square millimeter, let's take 35 square millimeters. That would be a standard size, which is double of the amount of this one, and that will of course reduce the voltage drop over this jumper here and over the long one especially. And I would say, of course, that is correct, but it's still a jumper and it's still a resistor, and there will still be a voltage drop on that jumper. And of course, for people who are having much higher currents on their systems, right, I only have 60, that's almost nothing compared to other battery systems. Maybe other builders, they have systems pushing 150, 250 amps through those wires, and they of course already need anyway a much thicker wire, their conductor there, and they have the same problem too. They have also Ohm's law with a much higher current. Of course the resistance of the jumper will be lower, but because of the much higher current, the voltage drop will then also be same high, of course. So you cannot eliminate those voltage drops over those jumpers. Now comes the questions, why do we even need to consider this? Well, I showed you I have a BMS which comes with a wire harness. I have 17 measurement wires there, and they are connected to every cell. This one is a cheap standard BMS. You can have a smart one, you can have a super smart one. It doesn't make a difference if you can look into that BMS using Bluetooth or not. The problem is always the same. And the problem is that when I measure inside the section here, I only measure from one cell to the other, initially via the bus bars, which do not have any voltage drop, but then there comes one measurement wire, then the next one, which has to be on the other side of the jumper. So it is including the voltage drop from one cell to the other when you have currents going over the system. But what exactly does that mean? For the cell voltage itself, let's take this one here, this setup. I have here a cell where I can normally measure my cell voltage. I have here 3.352 volts, and on the other 3.354 volts, so they are almost exactly identical. But if I measure now similar, the BMS have to measure, or this could be a balancer, right? From measurement point one side to the next one, I am reading now 3.386 volts. What was perfectly similar voltages on cell levels for the BMS, or let's say an active balancer, this one cell, including the jumper, has a much higher voltage. So it is actually out of balance. But it is not out of balance if you look at the cell. The cell is perfectly balanced. But still the measurement, what you see on the BMS, if you can read it out, let's say you have a smart one, right? You will see an unbalanced cell group there. And in my case, because I have 6 cell sections here, I would actually have 5 times I would see the unbalanced cell inside the pack where there is no unbalanced cell. What kind of problems can that bring for you? Somebody who goes really close to limits, right? It can be the upper limit. If I would want to charge this pack to 3.65 volts, what would be the maximum cell voltage for the BMS? Or I would go down to 2.5 volts. So those cells which do have the jumpers in between and seem to be unbalanced, so they will show always a higher voltage, right? Depend on the current, as I said before. That means the BMS would actually see a cell reach 3.65 volts before it actually happens. It would disconnect the pack too early. So if now your controlling of the pack is done by voltage or maybe by a column meter setup, you would actually have to disconnect sooner than it from the cell status would be necessary. And on the low end, it's a little bit more dangerous. Cell including the jumper will show still more than 2.5, but the cell by itself could already be lower. So that could also then damage already the cells. When you have some situation like this, it is very important, most important actually, that you stay away from any limits. Right? So you always need the buffer to be safe on the voltage, right? So for me, in my setup with the absolutely dumb, simple BMS, I'm running my pack only to 55 volts or something like this, and on the low it's 50 or 49. So there is a lot of plenty of buffer, and it doesn't really matter what the specific cell voltage is shown there in the BMS. It will never be somewhere close to a limit where the BMS has to take action. But for something like this here, where I made a cell monitor, or the BMS is a smart one where you can read out your cell voltages on a smartphone, right? There you would see now wrong readings. So in my case, where I have a cell monitor which is read out by a microcontroller, I can exactly say, okay, I have to correct cell number 3, I have to correct cell number 6, number 9, and actually subtract a delta V which is caused by the resistance of the jumper times the current which is flowing over it. So Ohm's law have to be programmed into the calculation of the voltages there. But let's say you now have an active balancer, one of the simple ones which are doing exactly the same thing like this BMS. They are measuring the voltage, and when the differential voltage between cells is getting a certain value there, it would start to bleed off the high showing cells into low showing cells. But now I told you, if you have a jumper, this is an additional voltage, is adding voltage to that one cell group where the measurements are taken. So now that cell group would show too high. So for the active balancer, that would be the signal, hey, I have to start balancing. But the cell behind is perfectly balanced. So the balancer would actively start to unbalance your pack, which is of course totally stupid, right? And the other problem in that regard is that if you say, okay, then I will only use the balancer when the current is 0, so only when the pack is resting. The problem with that is that might work with lithium ion standard chemistries, but not with lithium iron phosphate, because when this pack goes into resting, there is no chance that there will be a voltage difference shown anywhere, because these cells are going to a standard resting voltage when they are full. Voltages are same until the third digit you can see on this meter. So yeah, actually on this pack it would be completely useless to install an active balancer. It would completely destroy the balancing situation here. Why does this BMS not do any harm to this? This BMS is starting to bleeding a few milliamps away, just 0.1 volts, so 100 millivolts before more or less the maximum voltage. So I never come there. So here you can see that whenever you have a BMS balancer, whatever, with this system where you just plug in a wire harness and then you have your sensing leads, this would be the first one, the next one here, next one, so they going perfectly from cell to cell. right, and this one, but then I have to jump from there to here, so this is including then a jumper here, so that then you can continue again from cell to cell. Here again, this one is the last one here, and then I have to do it here behind the jumper again. And this is where the voltage is when there is a current flowing over the pack, are then adding up to the cell voltages. For everyone who is building such setups where at some point you have jumpers going from one cell group to the next, be aware that this problem exists. You have to consider the voltage drop on those jumpers, which do not exist at the other parts where you just go from one to the next in a very symmetrical manner. But then you have this asymmetric point where this voltage drop will occur. This you have to consider. However, in my case I'm ignoring it because I do not go to limits. But at least you have to know, if you look at the specific cell voltages, that you might see an error somewhere where there is no error. So there's only one chance if you completely want to avoid those problems, and those are BMSs which are individually attached to cells only, like for example the DIY BMS, or I don't know, I think Batrium maybe also, where you have the cell monitors. So every cell group would have its own measurement and is reporting this to the BMS, and so there you don't have this problem that you have an additional jumper, because the measurement would be here and then again here, right? But those sort of setups can cost a lot of money. And yeah, it is not necessary as long you are aware of it, that this is present, this problem. And yeah, if you know what you are dealing with, you can of course then easily understand it and avoid any confusion. Okay, so that's already all I can tell you about this. Thank you for watching this video. Please like, comment and subscribe to the channel. I see you next time.